Hello, welcome to calculus class. Today our notes are going to come from chapter 7, section 4. Yes, we are going back in time. And we are going to talk about the area of a surface of revolution. So you will recall that we studied volumes of solids of revolution, where we took some two-dimensional region, rotated around an axis to create a three-dimensional solid, and we found its volume. Well, from geometry, you remember that you could also find surface areas of three-dimensional figures. So that's what we're going to find for solids of revolution today. So you're going to need the formula for the surface area of a solid of revolution. It's going to be the integral from a to b, which would be like your leftmost x to your rightmost x. And then we're going to have 2 pi, and then we're going to have it multiplied by our function, f of x, and then times the square root of 1 plus f prime of x quantity squared dx. Now, this is if we are rotating it around the x-axis, okay? The formula is going to be very similar if we rotate it around the y-axis, a vertical axis. We're going to go, the surface area is equal to the integral from c to d, where c is the lowest y value and d is the highest y value of our region. And then we'll have 2 pi, and then we'll have g of y. So we need to have our equation with y as the independent variable. So it'd be like a x equals something about y kind of an equation. And then we multiply by the square root of 1 plus the quantity g prime of y squared dy. So this is if we're rotating around the y-axis. And for today's lesson, we are going to use a calculator. We're not going to integrate by hand. Keep it simple today. And we're going to round all of our answers to 3 decimal places. Okay? So, for our first problem, we have the function y equals the square root of x. And we're going to rotate it around the x-axis. And we're going to do this for x values from 1 to 4. Okay, so the first thing I want to do is get the derivative, because I will need the derivative in my formula for the surface area. So if I think of this as y equals x to the 1/2 power, I can use the power rule to get y prime. So the 1/2 comes down in front, x to the power of negative 1/2. So now I've got to fill out my formula. The surface area is equal to the integral from, we're starting at 1 and we're going to 4. That's given in the problem, lowest x to highest x, times, or the integral of 2 pi times, we need our function next, square root of x, times the square root of 1 plus the derivative that we just found, 1/2 x to the negative 1/2 power squared dx. And we'll put this in the calculator. So here we go. Can you see that? So we're going to go alpha window, option 4 for function integration, lower limit of 1, upper limit of 4. Then we'll have 2 pi square root of x times the square root of 1 plus parentheses 0.5 x caret button negative 0.5 power, close that parentheses, squared, get out of the square root, get out of the integral, dx. Okay, so what will that give me? 30.846. So the surface area is 30.846 for this solid of revolution. All right, let's try another one, number 2. This time, x is going to equal 2 times the square root of 1 minus y. We're going to revolve it around the y-axis, and we're going to use y values from -1 to 0. Okay, so again, just like in the last one, I'm going to find the derivative because I know I'm going to need that in my formula for surface area. So let's think of this as 2 times 1 minus y raised to the 1/2 power, and we'll use the chain rule. So x prime, the derivative of x, is going to be 1/2 times 2, which is 1. Copy the inside function, subtract 1 from the power, so that's going to give me a -1/2 power, and then multiply by the derivative of the inside function, which would be -1. So the surface area formula will be the integral from -1 to 0 of 2 pi times my function with y as the independent variable this time. So 2 square root of 1 minus y times the square root of 1 plus the derivative. So I've got -1 minus y to the -1/2 power squared, that's all under the root, dy. And that's what I'm going to put in my calculator to get the surface area. So let's see if I can get all of this on here together, perhaps. Alpha window, option 4 for function integration. -1 to 0 are my bounds on my integral. 2 pi times 2 times the square root of 1 minus, and I'm using x even though it says y in the surface area equation, because your calculator is going to just treat y like it's this x. You could just name it whatever variable you want for the purpose of the calculator, times the square root of 1 plus parentheses, negative, another parentheses, 1 minus x, close the parentheses, caret, -0.5, close a parentheses around the exponent, and then squared, get out of the root, get out of the integral, dx. So we get 19.836 is what that would round to. Surface area equals 19.836. All right, let's see here. Number 3. X is equal to the tangent of y. We're going around the y-axis, and we're going to use y values from 0 to pi over 4. So first, the derivative of tangent of y would be secant squared of y. Now, since this is a calculator problem, I want you to consider the fact that you do not have a secant button on your calculator. So how would we enter that in the calculator? We're going to have to use an identity from pre-cal, right? The secant is 1 over the cosine, and that's all squared. So that's how we'll have to enter it in the calculator. So we'll set up our surface area equation, the integral from 0 to pi over 4. And then we need 2 pi tangent of y, that's our function, with y as the independent variable, square root of 1 plus, and then here's where we would have secant squared of y, but since we're putting it in the calculator, we're going to have 1 divided by the cosine of y, quantity squared, but then I'm going to square the derivative, so it's really going to be to the 4th power, because when you raise a power to a power, you multiply the powers, dy. Or you could do squared twice, that's fine too. So let's see what that comes out to. Let me see, scoot this up at the bottom of my page. Okay, alpha window number 4, lower bound 0, upper bound pi over 4. 2 pi tangent x times, whoops, I don't want to use parentheses there, times the square root of 1 plus parentheses 1 divided by cosine x, close the parentheses on the argument of the trig function, close the parentheses around my whole fraction, caret button 4, get out of the exponent, get out of the square root, get out of the integral, dx. So we get 3.839. Okay, we just have one more example today. Nice, easy, short lesson. I would like you to pause your video after I put this one down and give this one a try on your own, then check to see if you get it right. For number 4, we have y equals 1/3 x cubed plus 1/4 x to the negative first. We're revolving around the x-axis, and we have 1 less than or equal to x less than or equal to 2. X values ranging from 1 to 2. So please pause your video, see if you can determine the surface area of this solid of revolution, and then push play to see if you got it right. Okay. I'm going to assume that you have returned after trying this problem on your own. Let's see if you got it set up right. The integral from 1 to 2, 2 pi times 1/3 x cubed plus 1/4 x to the negative 1 power, square root 1 plus the derivative, which was x squared minus 1/4 x to the negative 2nd power, all raised to the 2nd power, dx. Okay, so when you put that in your calculator, you should have gotten 25.280. I hope you got that one right. I hope that this is a fairly simple lesson for you. Have a wonderful day, and bye for now.